All of you. It's going to be an exciting day with a lot of exciting topics being covered, a lot of discussions that are going to be quite interesting. I want to welcome all the companies that have joined in as well. Some of you are logged in online on YouTube and Facebook. I want to welcome all of you. It's going to be a great session. And we've talked about some very interesting topics that are exploding all over the world, topics like ChatGPT and generative AI and all these big, exciting topics. So we're going to talk about that today. And it's going to be a great session, all right? But to kickstart everything, I want to invite the Dean of the School of Computing, Ms. Naomi Krishnaraja, to speak to all of us, and then we'll move forward from there, okay? So, Ms. Naomi, I'll hand things over to you.
Good evening, ladies and gentlemen, maybe IT professionals, I would say. Some are aspiring to become professionals. Some are already professionals in the industry. Then we have our CEO, Mohan Fernando. We have our director, Kishani Pereira. We also have our distinguished speakers today, Professor Bob Fisher, and we have John Isaac, and we have Professor Nirmali Veeratunga, and our moderator of the panel, a very exciting person, Dr. Ruwan Veerasinghe. He's going to contribute a lot to the country. He has been over the 30 years and would be doing much more with IIT in the future, and you will hear about it. So it's going to be an exciting talk. Welcome to it. I don't want to take a long time, but we know that ChatGPT has taken the world by storm since December 2022, and with generative AI, you're going to have a lot of exciting applications which is going to increase your productivity and improve your daily life. And so you're going to hear about them from these distinguished speakers. Thank you.
Thank you, Ms. Naomi. All right, first up we have with us Dr. John Isaacs. And Dr. John is going to talk to us about a number of interesting things. We're going beyond ChatGPT. We're looking at the future. But let me give a quick introduction to Dr. John. So he is the Dean of the School of Computing at Robert Gordon University, and as such, he's responsible for the strategic planning and the future direction of the school's teaching and research, having completed his PhD at Abertay University and starting to look for new challenges. Dr. John joined RGU in 2014. His principal research interest lies in visualization, modeling, and real-time simulation in aiding the comprehension of complex information. He also has a keen interest in political and social media analysis and has developed real-time visualization platforms to analyze these data. Right? He's also interested in developing and evaluating novel applications for mobile platforms, including smartphone and tablet systems, and developing applications which allow wider use and adoption of these technologies, especially amongst older and disabled users. So it's going to be very exciting. There's going to be a moment of question and answer as well. So please, after the sessions are over, right at the end, we will have opportunity for Q&A. So please feel free to jot down your questions as we go along and ask them at the end. And I want to invite even the audience online to do the same thing. All right, so this is going to be a 12-minute segment. And Dr. John, I hand things back to you, and I'll give you a little reminder when you reach the 12-minute ticker on the clock. Thank you so much.
The mic is on. Okay, thank you everybody for inviting me here today to give you this little talk. I will be about 12 minutes. I'll definitely be less than 12 minutes. Just kick me off the stage if I'm too long. First of all, I'll apologise for my accent. You might already pick up that I'm not actually Scottish. I grew up in Belfast, and I have a terrible accent and a tendency to speak too fast. So at any point you can't understand me, just shout and I'll come back and say whatever it is that I said in a much slower, proper English voice. So I'm Dean of the School of Computing at RGU in Scotland, in the north of Scotland, and we have a very particular problem in the north of Scotland that we're trying to solve by using conversational AI. Who remembers that first bit of code that they wrote that compiled? Come on, show of hands, right? Who remembers that first bit of code that they wrote that actually did something cool? Yeah? I remember mine. Well, the best bit of early code I wrote was the school I went to had a login system for its teachers. I copied the login system and stored all the username and passwords to a text file. So the next time I went onto that computer, I had all the teachers' username and passwords. Please don't publicize that, because it was probably illegal. You remember that first bit of code that ran, that first website you created, that first app, that first game, that first bit of code that you wrote. You'll remember that. As a computer scientist, as a data analyst, you go into any job in computing, you will never forget that first bit of cool thing you wrote. So what's the problem? That's now much harder to do. When I did that, it was a black screen and white text. And then we progressed to really advanced things like Visual Basic. Anybody remember Visual Basic? The people at the front maybe remember it a bit more than the people at the back. But it was much easier to do. Everything was new. You wrote a bit of code, and that bit of code was new, and it did something cool. That's now much harder for kids today. Why is it harder? Because computing is all around us. Computing isn't about computers anymore, it's about how we live. It's everywhere. Every car you drive in designed by a computer. Every bus has probably been planned, its route planned by a computer simulation. Traffic lights, aircraft, the buildings you're in, the central control system, everything. Kids see computers every day. So how do we get them excited about it? How do we create that penny drop moment of something cool happening that incentivizes them to go into a career in computing? How can we make an impact when, to kids now, that stuff on the screen isn't cool anymore? That text on the screen that may do something in the future isn't as cool as it once was to us. So what do we do? There are tools like Scratch. Anybody played with Scratch? Yeah, a few of you can see some nodding. Yeah. Tools like Scratch, the no-code, low-code solutions to help kids get into programming. They're brilliant, but in a world where computing is all around us, computers and computing is all around us, do we really want to sit kids back in front of a computer screen to introduce them to how cool computing can be? Do we really want to get young kids from the first thing they see is a screen, a big screen and something running on it? That's quite detached from the stuff they see every day. So the tech kids see every day is probably a phone or a smartwatch or some other kind of device. It isn't necessarily that computer screen. So is it right then that we try and get kids back behind the screen to do this? Or are there other ways of doing it? Can we not show the kids something different, something more connected to the real world, to the world as it is at the minute? So, conversational agents, what are we talking about? Little example here. We have a person, and a person wants to change their flight itinerary. So what do? They might speak to something like Alexa, Google, Siri, and say they want to change their flight itinerary. The system has a built-in speech recognition software, hardware, whatever, and it listens to that. It then can turn that into natural language understanding. It can take that information and turn it into something that the system then understands. It may send it directly to something called dialogue management. Dialogue management just controls how the system responds. When I say hello, what do you want to say back to me? Hello. That's dialogue management. The only difference is that the system, a little bit like us, has a set of responses that it will use to respond to that information that's been put in. So if I say I want to change my flight itinerary, it might say something along the lines of, what would you like to do with your flight itinerary? A dialogue tree of different paths in that conversation. Imagine a conversation like a tree. That's all the happening. The natural language understanding may turn what someone has said, particularly if they've got a terrible accent like mine, it will turn what they've said into something the computer can understand. That dialogue management then passes it back to something called natural language generation, which does the opposite, turns the answer into a nice conversation with the user. So that's a very, very dry and boring way of telling you what it does. What I'll show you now is a much cooler example. So hopefully sound will work. Hopefully sound and video will work. If it doesn't, we're in trouble. Oops. Let me see if I can get this to run. Oh. It's always terrible when you try and do a live demo.
How can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
This is an AI speaking to a real hairdresser's shop.
Sure. What time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you happen to be between 10 a.m. and 12? Depending on what service she would like, what service is she looking for? Just a woman's haircut for now? Okay, we have it 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day, guys.
So that's an AI, conversational AI, the one with the little Google symbol, speaking to real hairdressers, booking an appointment. And the hairdresser does not have a clue that they're speaking to an AI. That's what a conversational AI can do. It can speak to a person, and the person will likely have no idea they're actually speaking to an AI. That's how powerful these things are starting to become. So how do we use this type of setup, this type of example, to encourage children into computing? Well, we use it in outreach. Trying to inspire the next generation of kids using AI. AI is something that they will see. They will play with their parents' Alexas, Googles, and Siris. They'll be able to speak to these things and get answers from it. They'll know what an AI is, or an AI assistant is, simply by their friends, family, or whatever having them. So how do we use that to try and get kids interested in computing in general? One way is to use robots. This is us using Pepper, a robot called Pepper, in an outreach event with children in the northeast of Scotland. We take Pepper into the schools and we let Pepper talk about computing and about the courses that we run and the type of careers they could go into. And Pepper can have a conversation with the children to show them what it can actually do. I'll show you an example of Pepper in a minute. One of the other things we do is every year we have something called the Christmas lectures in the university. This is where we get in about 300 primary school kids and we introduce them to some part of technology. And for the last couple of years we have done fake or real Santa. Fake Santa is an AI. Real Santa is also fake Santa, but it's a member of my team dressed in a big Santa costume that sits outside the room. They're both on a phone and the kids shout out questions to them. And they try and identify which one's the AI and which one is the real fake Santa. What they're actually doing is trying to identify whether they're speaking to a real person. And when they do this, we then show them how the dialogue works. So they might ask, where do you live? One might say, I live in the North Pole. One might say, Lapland. We all know where Santa lives, don't we? Where does Santa live? Yes, right. So by asking questions, you try and we get the kids to try and work out what is actually going on behind the system, to work out what is a stock answer, what is a dialogued answer, and then they can try and work out who's real and who isn't. What we're essentially getting them to do is a Turing test. We're getting them to understand what a Turing test is and understand then what a conversational AI is based on the Turing test. Is it a real person? Is it a computer? Or is it one of my staff members hiding out in the corridor in a big massive Santa suit? And we then show them the differences between how humans respond and how a robot or an AI might respond. So a human might be faster. A human might be slower, an AI might be faster. A human might have some wisdom. You might be able to ask it a follow-up question that an AI wouldn't be able to pick up. AIs are getting better, and they're getting much better at these type of follow-up questions. An AI will often forget what you've told it before, because it doesn't necessarily have a memory of something you've already told it. It might not. The other thing about humans is they're much more likely to get annoyed. So you can wind up a human, whereas you can't wind up an AI. The other example we use to get kids interested is Pepper. Pepper is what we call an emotional robot. And Pepper has all the little bits of tech that we need to be able to listen to things and then to process a result. So Pepper can see if someone's standing in front of it. Pepper can hear if someone speaks to it. And Pepper has a voice and can respond. And Pepper can wave its arm about and dance and do all these other cool things as well. The perfect thing you want to get kids interested in AI. It just needs a little bit of help to be able to do this well. Pepper is now a full-time member of staff at my school that helps at open days. It's great. You don't have to worry about pensions or lunch times or anything. You can just get Pepper to do this.
Hello.
And people can go up to Pepper and say hello. And Pepper will start telling them about the school and about the courses and about the facilities and about the options to them.
Tell me about the courses.
And most of the time it works.
We offer the following courses: computer science, cybersecurity, computing and creative design, cybersecurity and network management, application software development, IT, management business, digital media, computing science and data science. If you say the course name, I can tell you more about them.
So Pepper can respond to anybody asking about any of the courses or any of the information about the school. Pepper isn't a real person. Pepper's a robot. Kids will run up to the robot and start asking about the courses much more quickly than they'll run up to me, because I'm obviously a very old, scary dean. They're not going to run up to me and speak to me, but they will run up to the robot and speak to it.
Show the list. Show the list. Show the list. Show the options.
Obviously, there were some bugs in this version.
Tell me about the facilities.
Thank you for asking.
There you go. So you can see Pepper responding to that conversation. Pepper's got a little display that can display stuff and also speak.
Cybersecurity. Green screen suite.
And you can see some of the dialogue being set up there as well. Okay, so what's the impact? So we use robots and conversational AI as part of a much wider outreach program with kids in the northeast of Scotland. A lot of it's based around AI because that's what our school is known for. We do little things like maze following. We get the robots to build get the kids to build AI cars and navigate around a maze. We then show them how easy that is to code with a language like Scratch. We then build that up to show them actually this little bit of non-code stuff you're doing at the minute, that's the same type of code that runs on this big complicated robot. There's just more of it and it's doing something more complicated. And we can take them right through to building things like chatbots and getting the robots to respond to their own controls. So a much more interactive way, using what is essentially cutting-edge technology to get kids interested in computing right from an early age and creating that little bit of a spark that perhaps they don't get because computing's everywhere now. There's a little robot, a kid getting the robot to follow a maze in our AI workshop. So, implications of all this. Large language models and generative AI, so things like ChatGPT, are being coupled with conversational AIs. Traditionally, conversational AIs will often work on a dialogue, but hooking these up to large language models means that you overcome that barrier of a conversational AI not perhaps knowing as much knowledge as a person would. So this is going to balance, and they're going to be much, much harder to spot. But still, they are going to be really, really helpful. And when we hook them up to things like robots, then it becomes even cooler. So children need to be inspired. We need to inspire kids into computing, and using these types of technologies are one way to do it. The reason why it's a good idea to do it now, there is no way children, even us, will not be using these tools in the next 3, 2, 1 year. These tools will be tools that are used. They will replace things like Google. They will replace things like a Google search. You're much more likely to go to some kind of AI search to find an answer to your problem. We need kids to understand that now, not 10, 15 years in the future. Thank you very much. That's me. Is that right?
That's fine. Dr. John, thank you so much. Wasn't that amazing? Can we give him another round of applause? It was brilliant. I'm sorry we had to shorten the time so much, but it was very exciting. It's very creepy to think that we're probably having conversations, or will be having conversations with machines, and we wouldn't even know it, right?
We already are.
All right.
We definitely already are.
Okay, so that's pretty creepy. All right. So what we're going to do is, thank you so much, Dr. John.
No problem.
So before we go into the next, we listen to the next speaker, so we're going to have Professor Nirmali come up in just a moment, but before she comes up, there's a quick Q&A, all right? And I'm going to ask you a question. I'm going to ask you 2 questions. Now, if you can answer those questions, you're going to win a prize. Okay, it could either be an IIT branded pen drive or an IIT branded notebook, right? Or an air ticket to the US. That's the joke, right? You got it. All right, so 2 questions. If you know the answer, please do raise your hand, right? And then we will see whether you get it right. Question number 1 is an easy question, and the question is, what's a popular term used for conversational agents? What's a popular term used for conversational agents? Yes, go ahead. Yes, chatbots it is. Can we give him a round of applause? Would you step up, please? You've just won yourself the air ticket. All right. One more round of applause, please. Thanks so much. And we have the second question. Now listen carefully. Okay, the question is, which of the following generative AIs are open source? All right, which of the following generative AIs are open source? You ready? Listen, these are the answers. ChatGPT, LLAMA, Falcon, Bard, Midjourney. Yes? Sorry? ChatGPT it is. Is it? No? All right, it's not. Yes? Bard is not correct. We're going through all the answers, right? Sorry, you said? Falcon it is. Can we give him a round of applause? All right. Well done. Thanks. Okay. Okay, thank you so much, guys. We'll have more of this later, but at the moment I want to introduce our next speaker, Professor Nirmali Weeratunga. Now, Professor Nirmali is a professor in intelligent systems at RGU's School of Computing. She has over 20 years of experience in computer science and artificial intelligence research and education, and is also an adjunct professor at the Norwegian University of Science and Technology. She's best known for her work on case-based reasoning for personalized decision support systems. She serves on numerous AI program committees. She also obtained her PhD in 2001 and thereafter gained a permanent research fellowship at RGU before being appointed to a readership in 2009, and her professorship she took it on in 2016. Her current funded research is developing a platform to reuse explainable AI experiences, including conversational AI, in healthcare. Her previously funded projects include EU's Horizon 2020 and Innovate UK projects on sentiment analysis for a product recommendation. All right. She also serves as the link coordinator for RGU and IIT validation courses. This includes the Masters in Big Data Analytics, the Masters in Business Analytics, and the Bachelors in AI and Data Sciences. Okay, I want to welcome, will you join me in welcome Professor Nirmali Veeratunga. Professor, it's over to you. All right.
Yeah, thank you. Good evening, everybody, and thank you for the opportunity to talk here. So my topic here is explainable AI, and it's somewhat different from the advertised ChatGPT, and you may wonder why. And the reason for that is explainable AI has matured as a research area, and the reason it came to be was when we started with deep learning and we had all these neural models which were black box systems, it became very clear that it was our responsibility to make sure that as AI developers that we find a mechanism to explain to people as to what's going on. And so we've gone through a long journey to try and create explainable AI, and we're on the journey towards making it a regulatory process. And so there are some lessons that perhaps that we've learned during that time that I think it's becoming very crucial and important for things like large language models to adopt as we move into the future. So my plan then is to tell you the sort of things we've done in explainable AI, and at the end I will try and highlight what are the parallels between explainable AI and large language models, and possibly what are the things that we maybe want to consider as we go forward. Right, so the type of questions we're going to ask is start off with what is explainable AI, what are the different types of explainable AI, how do we from that place move on to regulating and evaluating explainable AI, and how do we share best practice, and then finally draw some conclusions from that and see if that is applicable for the rapidly expanding large language models fields such as ChatGPT. So for those of you who may wonder what is explainable AI, it's very straightforward. It's about trying to look under the bonnet to understand why a particular model came up with a particular answer. I mean, if you look at the dictionary comment about what is explainability, they talk about things like the quality an object has when one can see clearly through it, the quality or a situation or process that can be clearly justified and explained because it's open to inspection and free from secrets. And that all applies to us when we talk about explainable AI. The important thing is it's not simply looking inside the box, not simply understanding why certain weights led to the triggering of certain neural nodes, but also trying to understand what was the input and the link between the input that caused the output. So there's this full process end to end that we must ideally try and be able to explain. So let's now, when we're explaining things, who are we explaining it to? We are explaining it to our end users, and these end users have different what we call intentions or expectations or explanation needs. So one of the key needs is we start off with interpretability. So this is about being able to interpret the output. So this is the focus is primarily about the output. But you might also want to know how the model works. So suppose we have a data scientist, their interpretability requirements may focus mainly about how the model was working in order to maybe debug it or find out why it said something incorrect when we know the answer should be something else. If we think about a different type of per end user, so let's say we are talking about a mortgage application system for banks, and you put in your mortgage application and the AI system gives you a prediction. And if you're a loan officer, the way you want things explained will be completely different from what a data scientist wants. Similarly, the end user who might get their application rejected might want an explanation that helps them to try and improve their situation so that the next time when they do apply, they might get a more desirable acceptance. So it becomes very clear when we talk about explainable AI that we have to think about the needs and expectations of these end users. And that's not enough, because after that, when we deploy these systems, we need to know whether the explanation actually met their requirements. So if we are talking about interpretability, we need to engage with them, and then we explore what sort of questions were addressed properly. So there are, in literature, all types of interpretability questions that we can put to them. So things like, from the explanation, I understand how this particular model works, and on a Likert scale, you can give it 1 to 5. So it has become important in explainable AI that we collect this type of information to be responsible, that we are providing systems that are meaningful and relevant to the people who are going to use it. So that's interpretability. Then if you think about medical domains, you get the need to help people to understand what's going on. Here's an example where we have a prediction system which generated all kinds of charts, but the clinicians told us, this was a project we did with clinicians, they said, well, we really cannot make sense of all these bar charts. Could you generate some language to us? So then we bring components such as natural language generation to try and explain things in human text. We might then want to explore the language that was generated. Is it actually useful to these clinicians? So we might ask different types of questions from them. Was it articulated correctly? Was the sufficiently complex? It turns out in literature, people do like complex explanations, because by complex what they mean is that you explain the same thing using alternative methods, and they like that. Was it accurate? Did it explain things correctly? Was it coherent? So there are certain things we want to ask our end users to make sure what we are generating with our language is actually meeting their needs. Trust is an important aspect as to why we want to explain things, particularly for a doctor. One person might want to know, why did you say this radiology or X-ray image was malignant? They may want a salience map. Another doctor might have a completely different need. They might want to look at precedence, and they might want to say, can you show me other patients who had similar diagnosis or had malignancy in a similar manner to see what kind of treatments worked for them in order to apply those techniques. So the important thing that we've learned with explainable AI is that we need to think about the end user, we need to think about their explanation needs, and we need a way to evaluate whether what we are presenting to them is actually hitting the right spot. Another area of research that has worked very hard in explainable AI is to try and use explainability to identify areas of fairness. So we all know, whether it's ChatGPT or any of the language models that we use, they are essentially using probabilistic models to look through large amount of content, using techniques like masking or next word prediction, and they're sort of, in a way, applying probabilities to all this content. And if the content has bias, that bias is going to appear in the language that is going to be generated. So that's where some of the threats lie, that if we don't understand that these systems are mimicking human bias, we are going to go to a not a very good position. So there was this really interesting piece of work done to try and understand this a little bit better, not with generative language models, but with deep learners, where they were using this learning model called Compass to try and actually use it for judgments of whether a particular prisoner is likely to re-offend or not. And they actually used it, I think, in Florida, in one of the courts, and knowing that the actual AI model was about 60% inaccurate, they still use this system. And since then, it has been shown that it has naturally a lot of racial bias. And so if you tended to be a black person, the system is more likely to say you're going to reoffend. It's because it has learned the human biases. Another interesting part from this study was that they found that a single method of explanation is not sufficient to identify that bias. So just using, I don't know, things like feature relevance is not enough. You might want to couple that with explain a technique called counterfactuals. What are counterfactuals? Like suppose you came here today in a vehicle and there was loads of traffic, and you might think, oh, I wish I took a different route. That's the counterfactual, because if I took that other route, I might not have met the traffic. So explanations also use counterfactuals. You know, if you had not done such and such, your mortgage would have been accepted. So what they find out is when you provide explanations through these deep learning models, it is important to provide different alternative explanations as well. In the West, certainly, we talk about the right to an explanation, and this is getting into regulation, whether it's the EU GDPR, and more recently in the UK, there was a white paper in March where they are looking at regulating AI and the importance of explainable AI. So we are in explainability at least moving towards the need to regulation, so that when you deploy an AI system, ideally you should have a checklist to say they have passed all these compliances. You know, it's compliant with A, B, C, and D before you can deploy. We're not quite there, but we are on the way to that destination. So currently at RGU, we are working on a project called IC, where we are trying to build an explainability platform that would help to share good practice, so that if we have a system where we want to deploy, it goes to IC, and IC would then recommend the right sort of suitable explanation strategy. It allows you to evaluate whether that explanation strategy is correct for your end users or your customers, and then get some indication whether it worked or didn't work, and perhaps modify the strategy before you can deploy it. So I'm not going to go into a lot of details because I'm running out of time. What I want to say is that that's a lot of work to be done. You have to identify what are all the different explainer systems. You need to be aware of what are the types of questions people ask. So we've done a lot of studies to identify that depending on the explanation needs, people might ask different questions. You know, again, they might have needs related to effectiveness, comprehensibility. They might be interested in debugging it. They might be interested in changing the outcome to a desirable another outcome. So depending on the requirement, we have to have a whole taxonomy of types of questions, so that our explainability system is able to handle all these details. Okay, so once we manage to identify the different explainer methods and the types of questions people are asking, and we can evaluate it, then we are in a place where we can think about regulations. So with IC, we are now almost 1.5 years, a little bit more than that into it, and we are at the place that we are able to now bring together use cases. So in a use case, what we do is we talk with a company and we try and understand the user context. What are the different types of users you have? What kind of deep learning models do you use? For this type of deep learning models, what kind of questions are your end users going to ask? And we try and model all that. We put it into the platform, which is essentially a recommender system, which then generates the explanation strategy. And importantly, we also move on to a session where we do an evaluation to see whether that strategy worked for the end users. Right, so it is vital, at least in our research, to work with companies and people who develop these AI systems, so that you build these use cases into your regulation platform. So that's where we are with IC. I just want to now talk about, okay, having done all that with explainable AI and given the recent rapidly expanding large language model fields, what is the connection between these two things, right? So, if you look at key characteristics, they are both assistive tools, right? Explainable AI is there to help you to trust the system, to understand the output in order for you to make a decision. ChatGPT also helps you to do that, whether you want to write an email, you want to write a poem, you want it to generate code, it's trying to assist you to do something. The key thing about both of them is that there's no ground truth. They generate something, you have no idea whether it is good, bad, or right. So that is an important thing we need to consider. And we need to build mechanisms of this notion of accuracy. How do we measure what they are generating? Is it correct? You know, in which ways is it correct? Then from explainable AI, we know that this problem has been solved by using a human-centered approach, by bringing humans into the loop and bringing in qualitative evaluation. It may be the case that if we think about regulating these type of language generation methods, we might have to do the same thing, to have humans try and evaluate it, but also try and understand that a human's mental model or understanding is completely maybe not aligned with what that language generation method is providing. So some people might just completely believe it, and that could be dangerous for our democracy, because it may say anything and anybody might believe if you don't understand that there are errors in what it is generating. So understanding end user's mental model and how it is different from what is actually happening is very important. And then finally, what's important to understand is all of human biases are likely to be in there. In fact, it is there because there are studies ongoing that demonstrates that these language models demonstrate all the biases like anchoring, framing effect, confirmation bias, and also mansplaining. In case you don't know what mansplaining is, I suggest you look up Google. And so we need to look at regulations that try and address those issues. It was interesting in John's presentation, he showed that Turing test. I'm now beginning to doubt the Turing test. Actually, I was a strong follower of Alan Turing, and I thought it was excellent, you know, the Turing test. But the issue is it correct to mimic humans like that? I mean, I heard another discussion recently which said, if you counterfeit money, what happens to you? You're going to go to prison, right? So why is it right to counterfeit a human? Why should that be a correct thing to do? So we need regulations to try and help people not to pretend to be humans. It's okay to say, look, I'm a chatbot, right? So that immediately you make humans understand, I need to take this with a touch of salt, you know, pinch of salt. So there's a lot that needs to be done. I will conclude with these points then. All these explainable AI, deep learning, and large language models, what are they doing? They are influencing our decisions. That's the power. They have that inherent power. What are we doing? We are offloading our cognition to them. That we should be cautious of that. Is it an existential threat? Maybe Ruan will try and tease that out from us. There's lots of things we need to do. But I think explainable AI and the route that we took in that journey also has a way to help towards achieving some of these threats that we have. So thank you.
Thank you so much, Professor Nirmali. That's exciting. Excellent. So the discussion about how you know, the legal aspects to all this is going to be, I'm sure, something that's going to materialize very soon, because they are moving so fast and so rapidly. And I'm looking forward to the panel discussion. I'm sure some questions are going to come up. So please, just a reminder, if you have questions, please feel free to jot them down from both discussions we've had so far, both presentations we've had from Dr. John and Professor Nirmali. Please have them ready, and during the panel discussion, you have the opportunity to ask questions. All right, 2 more questions that I'm going to raise now, and I'm going to see whether you've been paying attention, right? One is a very simple one, but let's see who gets it. So I'm going to, I'm not artificially intelligent, okay? So I'm just going to use my visual sensors to see who raises their hand first. And I've got to pick you. So question number 1 is, what does XAI stand for? I saw you first. All right. That's right. Explainable artificial intelligence. Can we give him a round of applause? Thank you. Thank you. Question number 2. Now listen carefully. This is a tricky one. Okay. Which of the following is not an XAI tool? Which of the following is not an XAI tool? Lime, Orange, SHAP, Shapash, Skater. Oh, I can hear crickets. Yes, ahead. Which one? Orange it is. Good. Can we give him a round of applause? Thank you. All right. Okay, we're going to go into our third presentation, and our third presentation will be delivered to us by Professor Robert Fisher. Professor Fisher has been an academic in the School of Informatics, that is at the University of Edinburgh. Okay. Originally, the School of Informatics was the former Department of Artificial Intelligence, and he's been there as an academic for over 40 years and serves as a full professor for over 11 years. He received his PhD from the University of Edinburgh back in 1987, investigating computer vision in the former Department of Artificial Intelligence. So Professor Fisher was the head of Graduate School 2020-2021 and now serves as the Director of Internationalization 2021 to all the way up to 2024. He also serves as the Treasurer of the International Association of Pattern Recognition, or the IAPR, and has been elected an IAPR Fellow. All right, ladies and gentlemen, I'm not going to take any more of the Professor's time, and I'd like to invite you, Professor. Thank you so much for being with us. I hand over the stage to you for the next 12 minutes.
And, I'm happy to work with the stage mic. Yep. There we go. Right. Good evening, everybody. So, do any of you remember the red thing here in the picture? This was a movie that came out really big about AI and robots and killer robots and all that stuff before all of you were born, called 2001: A Space Odyssey, and it kind of gave an indication there of something about what a robot might see, or an AI agent might see. And I'm going to demystify all of that and tell you what a load of rubbish it all was, but it makes for good cinema. And okay, so we're here talking about robot seeing, and let's start with the fact that actually they use quite a variety of sensors. And can we think in terms of like TV cameras or something like that? But actually there's a whole range of things that people actually use in the building of robots, and I'm going to show you a little bit of examples of all of these, just to so you get some feeling for all the different kinds of data that you get. And after we talked about the sensors, then we're going to talk about what we do with them. Okay, so everybody's familiar with color cameras connected up to a robot, and here's an example of a lovely parrot picture, but in actual fact that I'll just carry on. The actual fact is that a color picture is not really a picture, it's actually 3 pictures. The cameras that you use actually encode a red, green, and blue picture, okay, and what the robot actually sees is the gray things to the side of it. It sees 3 different images emphasizing different aspects of the scene, or whatever it is that you're looking at. When it comes to video cameras, okay, we think in terms of the world just moving, zoom, 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 like that, and everything is continuous and flowing, but in actual fact, it's a bunch of still images all stitched together. That's what the robot sees, and a bit like what's shown at the movies. And again, each of these different images is broken down into the red, green, and blue type images. So somehow, you have to analyze a whole set of images, or the robot or computer has to analyze a whole set of images one at a time. What's now becoming a little bit more interesting is that in your autonomous vehicles, often they have some kind of a depth camera. There's quite a variety of different ways that you can get these depth images. And what you see on the left is a kind of a standard gray image, and on the right you see a depth image that can be measured from one of these scenes. And in this case, the brighter the image, the closer it is to the camera. This is very useful if you have an autonomous vehicle and you don't want to bump into things. That way you can sort of see what's nearby and what's further away. Now let's just see if we get lucky here. Where's my cursor? I don't see. Come back. John, how do I need help here, John? Yeah. I can't find a cursor. Okay, well, at least it looks like the YouTube is popping up. Okay. Yes, unfortunately we have adverts to go in the front of all these little...
Microsoft's Kinect has a depth sensor that can tell how far away things are. In this stream, brighter colors are closer and darker ones are farther away. This video will explain how it does this, which is
that's enough.
Initially thought it worked.
Yeah, so I'm just showing you a little clip, so you could just...
wanted to figure out how far away things were from a camera.
Okay,
how can you tell the difference between a small nearby rabbit and one that's larger but farther away? They both could look the same from the perspective of...
There we go. John, don't go far. I'm going to need you. Okay, so that was a little bit of an example of a depth video, and now the next one we're going to look at is a LiDAR type camera, and this is very common on autonomous vehicles. Again, it's kind of like a depth camera, but it doesn't give you a full depth image like you get like a color image. It just gives you a set of points about how far away everything is. And you can see an example of the car in the middle, and then it's got all the little green dots are all of the depth points that it's measuring around you. And in this case, there's also a little box that's been drawn around where it's identified a car in that video data. Another kind of camera, which is really more exotic, is called an event camera. And it doesn't really record the picture that you see, it records where something in the picture changes. Okay, and you can see on the left-hand image, you can see it in like the input image, and on the right hand, you can see a bunch of black and white lines. And the black lines are where an object is moving in one direction, and the white lines are where the object is moving in another direction. So it tells you about the changes that are happening in the scene, and this is maybe again useful for detecting in a car when an obstacle is approaching you or something like that. And I'll try and... John? Sorry. You're earning your money here. Yeah. I think we found it. Do we know? Okay, so here you can see an example of the event video. The person on the left, and then and then all the changes of where they've moved back and forth on the right. And one of the advantages here, it throws away all the color data and just focuses on where the changes are. Oh, don't need that advert. We can kill that. Oh, I see what the problem. Oh, wait. Right. Okay, so that gives you a little bit of an idea of some of the different kinds of sensing technologies that might be built into your robot. And now we're going to talk a little bit about, well, what is it we're going to do with all of that information? Okay, and generally they sort of fall into sort of three different categories. It's sort of what am I looking at and where is it? This may be useful for your car example that I talked about. It's also useful for factory automation. The next thing is things to avoid. Okay, that's definitely in the case of kind of a robot car or something like that, but it's also useful for people who have visual perception problems, disability or whatever. They can use it for avoiding obstacles if they're walking around, if they're blind, for example. And also things to work on. What are you going to do with the things that you see in front of you? And that, I mean, for example, factory automation or kitchen assistant, robot cooks and things like that. We'll use cameras for this. And so this is a rather busy slide, and it's sort of intentionally so. When we think about seeing, we think we see kind of the whole world and we understand it as a whole, but actually the computer vision field is broken down, that seeing, into actually seeing lots of different kinds of things. Okay, so in the upper left, you have a picture of a bedroom, but there's also little red labels on everything telling you what the things are in the scene. So sometimes we want to know what are the things or what kind of scene it is, just is it a bedroom? The next one to the right sort of tells you about where the different pieces are, and the third one, and also the third one, and then finally in the far right-hand side, it sort of tells you about the orientation of things, what the shape is, where they are positioned in the scene. And in the bottom, they tell you different kinds of things, again, that people are interested in the area of computer vision. And finally, in the bottom right, they're saying, well, if I understand what I'm seeing, I ought to be able to rebuild a model of it, a computer model, and that's what the bottom right-hand corner shows you, is a kind of a resynthesized understanding of that bedroom. When it comes to outdoor scenes, in particular, I mentioned autonomous vehicles a number of times, you get the kind of analysis that you see in this particular image, where you see in purple where the road surface is. So that tells you something about where drivable regions are. You can see where the different signs are. The robots will look at the signs and say, you know, is this a stop sign, or is this a speed limit sign, something like that. You'll look and see where the buildings are, where the other vehicles are, and things like that. So it's analyzing that information. And it's important to be able to detect and track people and animals and stuff in for your autonomous vehicles. So that's another application. And it comes to factory automation, then the robot needs to know exactly where the vehicles are. Generally, you know what it is you're working on in this case, so it's not so much a question of what is it I'm doing, it's a question of where, because the robot needs to make small adjustments of its robot arm to do the welding or install some glue or install a component, something like that. And then the last thing I'm going to do here is, so this is a gardening robot that my team and a bunch of others funded by the European Commission built. It prunes roses and it prunes bushes, and it's the only gardening robot in the world, so we were quite excited about that. And what you see is the robot itself with a little robot arm mounted on top of it. When it comes back to the sensing, one of the main ways that that robot understands the world comes from this little construction on the left. That's actually 10 cameras put together into 5 stereo pairs, and allows you to build up a full 3D model of the world around you. And what all those 10 cameras see are what are shown in the 10 frames on the right. So you can see where the garden is, you can see where the trees are, you can see where the bushes are, and then the robot arm can go out and do things with that. So I'm going to show you, here's a little, come back. It should, there should be a video playing. I can't read the error message. there's an embedded video that should be. Oh, there it is. Right, so there you see the robot kind of going out into the garden, and it's got its camera at the end of the arm. It's also got a cutting head down there for, in this case, it's going to be pruning one of the rose bushes, and it's building up, busy scanning that rose bush, so that it can build up a three-dimensional model of that rose bush, and then eventually it will come in and start cutting. Let's see if I can. So as all good gardeners know, you don't cut the rose plant straight, you have to come in at an angle, whatever, and that's what the, you can see the arm of the robot sort of turning for that. Okay, so while we're busy watching that, I'll just have a quick little conclusion. Seeing, in the case of the robot, is not just using a kind of camera like the eye that you have. There's a whole bunch of different types of sensors that robots use. And also, from that data that you get from the robot, there's lots of different things that you do with it, extracting all sorts of different kinds of information. And I think I'll just end up there, and then we'll have some questions later, maybe. Thank you.
Professor Fisher, thank you so much for that session. I think in the next maybe 10 years, we'll see so many machines around us that will just be normal to us. And now there's a lot of science fiction attached to it. Thank you. But it's going to change very rapidly. Okay, so we have another Q&A session for those of you who are ready to answer another question. The question is, let's see how many of you paid attention to that presentation. Okay, question number 1 is, what type of camera records the changes in the image? What type of camera? Yes? The event camera. Well done. Can we have a round of applause, please? All right, excellent. Well done. Another question. Now listen carefully. Right? Which of the following is not a type of vision system? Not a type of vision system, okay? 1D vision system, 2D vision system, 3D vision system, area scanned, 4D vision system. Yes? 1D vision system, is that correct? Dr. Run? No. Yes? The 4D vision system is correct. Well done. Lift your hands together. Thanks a lot. All right. Okay, so next on the list, on today's agenda rather, is a panel discussion, right? So I'm really excited about this. So I hope you've got your questions ready. And I want to introduce the moderator for the panel discussion, Ms. Naomi. Earlier on mentioned him before as well. But I just want to introduce Dr. Ruan. Would you put your hands together and welcome Dr. Ruan, who is the head of data science at IIT. And together with him, I'd like to invite our speakers. Thank you so much for being with us once again, Dr. John, Professor Nirmali, and Professor Fisher. Thank you so much for being with us. Please do take a seat. Dr. Ruan, I think you'd probably like to use this, or you'd like to use the main? Okay, great.
Thank you. I hope everybody can see the panel. There's a big podium in the middle. Yeah, maybe we come forward a bit. Yeah. Yeah. So first, I think there was an important point that was missed when you were introducing Nirmali. I mean, just to encourage some of the students who are here, she's also alumni of IIT. So we organized this because there's a team from RGU here, and I understand some of them just came today. John, yeah, so probably very tired, as probably some of you are after work. We saw initially something about the whole area of conversational AI, which has now evolved to be generative AI. But then we titled it Beyond Generative AI because just those generative textual AI will not be what we will interact in the future. And so the last talk was about the other side of artificial intelligence that requires interaction with the world, sensing and interaction with the world. And then of course Nirmali talked to us about something really, really critical going forward, and that is how do we make these AIs accountable, explainable AI. We are open for questions. Maybe till the questions come from our audience, I can ask something that people are kind of curious to know from each of us, right? Is this whole question about the singularity. When will this intelligence become such that it will make life quite difficult for us? Any of you have an answer? Because you may say never, or at the turn of the century, or or in 5 years' time or 3 years' time. It'll be interesting so that we can get some till we can get some questions going.
Well, I think when I started my PhD 40 years ago, I thought we would have robots in the houses and helping us out by now. And now that I've seen how slowly progress has gone, I would say 100 years, 200 years, it'll be gradually getting better all the time. And are we going to have killer robots like you have in the movies, like Terminator or Skynet or something? I don't believe that will happen. I think we can get AI to kill people just by the mistakes that it makes so quickly that we just can't recover from them. So you put it in your airplane, the airplane will crash faster than the pilot can pull the stick back or something like that. I think we've seen examples of close to that already. Anyway.
Cool. Yeah, the singularity. I suppose ever since the 90s, probably earlier, people have talked about the singularity and AI suddenly becoming self-aware and taking over. I think what we need to remember is that the AI we're seeing at the minute looks really cool, looks really clever, but it's a generative AI. It looks at existing information and creates new information from that existing information. It isn't, it isn't creating, essentially it's creating new knowledge, but from existing content. It's not taking over the world just yet. So I think we're a wee bit far away from the singularity, but pepper does sometimes glow red and look quite evil, but I think we're safe.
I think I would also agree with them that not yet. I mean, I suppose ChatGPT, there was a huge boom, and I think I can't remember the numbers, but it's reported to be one of the AI systems that have had such a rapid uptake by the public. So if it's going to move exponentially in that type of speed, maybe we need to be careful, maybe we need to plan better. So I think a lot of the warnings we are hearing is about not that AI is always a bad thing, but if we don't take stock, slow down a little bit and try and put in place the checks and balances it could go to the wrong hands. So if it goes into a sort of like a totalitarian type of people's hands, they are not going to be bothered about checks and balance, right? They will simply use it to thinking it's their benefit, but it will backfire on everybody. So I think it's a difficult question to answer one, but I think it's certainly the time to be cautious.
Thank you. I'm just looking around to see whether there is anybody with a burning question out there. You can just raise your hands, and I think a mic will make its way to you. Or if somebody is looking online, right? Yeah. Any questions from the floor? Okay, I'm sure there's a question. Yeah? There's a question. There are lots of students here. There's a question about, will an answer by ChatGPT be okay for your assignment? I think we're going to talk about it later, but yeah, maybe John.
Yeah, I'm happy to take that one. Is that on? Yeah, it's on. So I'm looking at some policy around this for my own university, and some of the background research I've done. ChatGPT, if you put your coursework question into that, it'll give you an answer, and you'll probably get a D. Right? So it's not going to get you an A or a B, it's going to get you a D at the minute. And do you want a D and a chance of being caught for it? So it will give you an answer, and they will get better, but at the minute you'll give a better answer, and that's the way it's going to sit for a while. And most universities will probably treat this the same way, that we're not going to stop you using it, we're going to train you how to use it properly, and that's what it's about. These are going to be tools that are going to exist for decades. Something new will come along in the future, but these are tools that are going to exist for a long time. As I said before, when you go into the workplace, you'll use these tools, so we need to train students how to use them properly now and use them appropriately, and not ban them.
So about 20 years ago, the web came along, and the first thing that happened was the universities went into a panic, and they said, oh, students are not allowed to use the web on any of their homework or essays or anything. Okay, and then Google came along, and then the universities went into a panic and says, oh no, you can't use Google. Okay, and then Wikipedia came along, and they said, no, you can't use Wikipedia, it's got too much information there. And now we're in a panic with ChatGPT. And my view of it, it's going to be a great tool. One of my kind of people I work with said, I need a shell script. So he went to ChatGPT and said, I need a shell script to do the following, and it gave him a shell script. But it didn't quite do what he needed, but it just gave the basic framework, which allowed him to then tinker with it a little bit and get what he wanted. So it was a good place to start. Okay, it's a good tool, and I think we're just going to have to learn how to use that as a tool. I also wanted to give you an example of where AI goes bad, and it's not because of AI, it's because of people. There's surveillance cameras all over the place, and some countries have put a lot of effort into video cameras everywhere, and also face recognition everywhere. And they know who you are, and they know where you are at every minute of the day. Okay, and it's not just, so the face recognition is a kind of product of sort of many 20 or 30 years of research in AI. And it's a very successful product, and you use it in your camera all the time, and you use it in your phone all the time, and things like that. It's very helpful, but it can also be abused. It's not just cameras. Anytime you walk around with your mobile phone, you're generating lots of data. AI is busy harvesting all of that, so it knows where you've been and what you've done and what you've ordered, which apps you've looked at, all that kind of stuff. AI is sort of hiding behind all of that. That's not to say that the AI is bad. It's just people have decided to make inappropriate choices of analyzing all that data, and that's I think the big problem is using AI as a tool leverages the power that people have to do bad things.
Thank you. Any questions? Yeah. And Nirmali.
Yeah, so I would agree very much that it's a tool, assistive tool for us, and it will become something like a calculator, I think, in the future. I think the AI literacy part is very important, as John said, that we need to train people how to use it, because a lot of research is showing that it has things like this thing called a framing bias. So, for example, humans, if you say that, ask them to do things or say things in different ways, they may respond a little bit differently. So if you add some additional things and say the question in a certain way, the answers come differently. And that same bias is observed in ChatGPT. In fact, they had done a study in code generation where they sort of redundantly add certain commands which are not relevant to a particular task. And those redundancies lead to different answers, not necessarily correct. So they have those biases. Then there's another thing that it does is things like what they call confirmation bias. So we all have these biases, and humans tend to be quite subjective based on these biases. So if I'm talking to someone, maybe Mohan, and we are talking about some important political issue or something, I will be always looking for points to confirm my bias. And what this means is when we are provided with a lot of information, we don't pay attention to all that information. We sort of quickly try and find things that confirm what we believe in. So one of the things that these generative systems also need to do is when they generate things, to try and ensure that humans pay attention to all the places of error and places of differences by some mechanisms. Those mechanisms are not quite there. But one thing I did notice was, like, if you go from ChatGPT 3.5, it's also very fast. That's a different story. But if you go to ChatGPT 4, it structures things a lot better. And I think that structuring makes you pay attention to sections. And it's good to do that because it makes you engage with the material. Suppose you ask it to generate an email, for example, and if you don't pay attention to what it is generating and you sort of just take it and try and send it to somebody, that could cause unnecessary problems. So there are some interesting things where we need to try and, create that AI literacy so that people can use these tools in the right way, knowing currently the areas where they don't do so well in the generated content.
Thank you. Anything from the audience? Yes.
Actually, question is to you. So I took your mic and when you were explaining about the explainable part of it. Now, human explanations has perspective and biases, right? And in a field like this, which is very universal, how do you, do you guys have something, a unified agreement, like what's the perspective that we will take, or it is kind of a moving target when you go to explainable AI? What I'm saying is, like, depending on the groups around the world who are doing that, is explainable AI is subjective to the region or the group that you are doing, or you are reaching sort of agreement, like this is how we're going to go about, because otherwise it's going to be very complicated, isn't it?
So if I understand the question, it's about how does explainable AI deal with these issues of subjectivity and issues of fairness. So I wouldn't say it's completely solved, but what explainable AI is demonstrating is that there is a need to involve the use cases, so very important to involve applications, the end users, and in terms of the machine learning algorithms, there's a type of explanation technique called the counterfactual one, particularly. It is very relevant because what happens is if you take some protected attributes, suppose sex or gender or age or whatever, and you change those protected inputs, you ideally don't want to see that the model generates a different output, because that is an indication of bias. So often that causal relationship between the input, particularly protected attributes, and its impact on the outputs allows you to get some notion of an indication that this data is causing some kind of a bias which the model is beginning to has adopted. So once you are able, that's the first step of trying to detect that, and thereafter then you need to try and find ways to minimize by probably cleaning the data or having some regulations as to how to address that by providing some seed data that is hopefully cleaned. Does that answer? Yeah.
Yeah. I'll stand.
So my question is there anybody working on explainable LLM now that everybody is
Good question. Yeah, that's actually a good question. Not a lot at the moment. So for example, there are certain techniques that were used in deep learning where they look at things like salience map, and the particular one that comes to mind is integrated gradients, where they sort of back propagate and they go to the inputs and say which parts of the inputs generated the outputs. So those don't naturally provide useful information when this is generating a lot of text. So I think we need to consider what is explainability when it comes to generative text. What they have done actually, however, is a lot of evaluation with humans to try and understand these types of biases. So there's lots of work going on in that, where they sort of create test situations where they know what should be the output, and then they can try and compare it. But the explanation part, I think there's still a little bit more to be done to understand what is explainability for language and LLMs. Yeah.
Yeah.
I have a question for the speaker who did about the explainable AI. So I have two questions actually. The first is about accountability, and the second is about, I'll ask a question and you will understand. The first question is like, I'll state a scenario. Like we humans, 90%, 99% of humans believe that a flawless sentient being, such as a God, created humans. The flawed beings like humans. We have corruptions, we have bias within us. So let's move on to the present day and age. So we are the God in this scenario and we are making the AI. So in your statements that you explained that you are, we are hoping to move on to a AI that would have the full 100% accountability on its part. Can we do that because we are corrupted and biased beings? So we are making AIs based on us, so could that be achieved? That's the first question. The second question would be that you said you are not agreeing with the Turing test. So you are saying that we should not make the AIs based on our image. They should be sentient things. So I'm asking if we made it like that, would it be a problem in the future? Because they would think, why do we need to obey the rules and the physics and all the things about humans that has many flaws? Why do we need to follow that? So
Yeah,
that's
okay.
the question.
I'll maybe take the second one first. So yes, it's recently that I've begun to think about the Alan Turing's Turing test. It worked fine when we were doing just machine learning and comparing is the decision correct or not, and can we differentiate. But when we talk about these generative ones, and even the example that you showed with the human doing the chat bot trying to do the hair appointment, that was harmless. But what I was trying to say there was It's not the mimicking which is dangerous. The danger is when you mimic and the human does not know, right? So suppose in a lot of these political scenarios, what they try to do is they try to brainwash people and convert them to one, usually to their benefit side, right? If we put people to go and do that, it takes a lot of our time trying to convince people and so on. But suppose you put a chatbot or a person that seems like a human but is not. They can spend as much time as they like chatting with this person. They have nothing to lose. They're never going to change their opinion, but they may change the human's opinion. So the fact that the human didn't know that they were talking to a chatbot or something, I think that is probably the danger. So I think there needs to be regulation that makes it the case that if you create AI of that nature, if you don't indicate that that is an AI, it should be punishable by law. It's the extreme that I'm saying, because if we counterfeit money, what happens? You go to prison. So why is it right to counterfeit humans? So those are the sort of things I think people are beginning to think about. That's what I meant. I don't know if it was clear when I was saying that. Yes, but there are also arguments against it now, because suppose you sort of, I don't know, create, think of a pharmaceutical company or the biological sciences. They don't make their stuff available. Imagine if they did make that available, people will be cloning, people will be creating viruses, they'll be doing all kinds of things. So if there's such regulation for those sciences, why do we not have that for computing? So people are beginning to now kind of question, should we have things open? I don't know, so that's quite interesting. What the first question was about the biases, isn't it? Yes, so all the research is showing that because these generative models are being trained on human-generated content, naturally it's probabilistically learning all the biases. Obviously we need to do something to try and, I think it's linked to Mohan's question as well, how to address that. And I think research is focusing on that area. But about this God and human thing, I mean, sometimes you could question and say, well, are humans actually intelligent? Are they so intelligent that they are trying to create something that could destroy them? I don't know, an intelligent biological system might not do that. They would be careful, they would put the regulations and make sure that that does not come back to bite them.
One of the fears by the society is that it will make the richer more richer and the poorer by AI. Is there any truth in this statement?
I can try and come up with an answer. I don't know. I think it depends how accessible it is. I think that ChatGPT in particular democratized the use of AI a little bit. The models existed for a while, and then a chatbot got put around it that meant anybody could then interact with it. So I think in one way it may give people who have, obviously you need access to technology, but it gives people access to technology they wouldn't usually had before. You can access it on a mobile phone. You don't need a big supercomputer to generate the answers. So in one way, yes, it democratizes it across people who already have technology. The other problem, of course, is does it do that for people who don't have access to technology? And of course, the answer is no. If you can't access the AI to ask questions, then you can't access it. So it could be causing a disparity there. I think the answer is we don't know yet. We don't know whether that split will get bigger or there'll be more access to technology. It's something that we'll need to try and prevent, but we'll need to keep an eye on. It's a really good question. I'm sorry I can't answer it, but really good question.
And my other question is, Professor Fisher, you have seen in mathematics using logbooks to calculators. How important is education in preparing the next generation to live with AI with so much biases and uncertainty?
Complicated question for which I'm not quite sure what the right answer would be for that. I think with regards to like your first question, is it going to redistribute the wealth? And I think in a kind of way, I think the people who can use, advanced AI type tools will have skills that will get them into good jobs and essentially pay them well. And there is a concern that this kind of technology may remove a lot of the middle layers of types of jobs. I mean, it'll never replace a nurse, but it might replace a travel agent, that kind of thing. So I think there's an element of that. That there will be a change. Any new technology, I think, involves a redistribution of wealth. Whether it will make it easier for everybody or not, I don't know. I mean, an example is like Wikipedia. All of you have access to Wikipedia, and in probably, certainly in English and possibly Sinhalese and Tamil as well. And you are probably a much more well-informed group of people at your age than I was at your age, just because you have access to so much more information so easily. And will this make you richer or poorer is a bit hard to say, but it certainly makes you more well informed.
Maybe just to add to what Bob was saying, the Wikipedia is an interesting analogy to consider with respect to GPT. So we have access to Wikipedia, and the thing is, when you say Wikipedia, you have some notion of authoritative text. It has been, approved by somebody, and people have approved it, and we know that's the Wikipedia page. Similarly, you might go to another web page where some person has written a blog, and as soon as you see that Wikipedia and that other blog page, you get a notion of which of these has provenance, which of these is likely to be of good quality. Now, the danger with ChatGPT is we have lost that. It is simply generating something which it has acquired from, whether it's Wikipedia, Reddit, or somewhere else. We have now lost the ability to know where the quality of it. So I think, Austin, you asked a question about explainability, and I think a lot of it is about trying to explain the provenance of the content from where it comes from, because at the moment we cannot know.
Hi. So, I wanted to say is recently, over the past months especially, we've seen really impressive advancements in AI-generated art and music, especially more of the creative fields. And I really wanted to know is how do you view these improvements and how AI is affecting creative fields, especially?
That's another really good question. I'm going to go out there and say I don't think they're improvements. I think that art and culture is part of who we are as a society. And again, you need to come back to how these AIs work. Large language models, they generate content based on existing content. Now, if that existing content, that music and that artwork didn't already exist, it wouldn't be able to generate anything. And it could become a time where, if nothing new is generated, the AI itself will just generate the same thing again and again and again. So, yeah, it's cool. It can generate cool stuff. It can generate good images. It can generate nice images. But I think at some point you're always going to need artistic input to get new art or music that has cultural significance. Otherwise, it's just a repeat of what already exists. But that's my own personal opinion, and it may not be the opinion of anybody else in the room.
I think I agree with you as well, John. A small difference, I think, with the generative approaches is that because they can mix and match, so they're not copying and presenting exactly the same thing. They might be merging from different music scripts or different artistic styles, and that creates, in a way, you could argue something new, but still that mixture is based on what already exists. So if you think linking and mixing things together, it's creativity. It is doing creativity, but it's not having that jump of the next level, which John mentioned.
I think we could think of it as a tool. So at the moment in the animation industry, they're probably very excited about this. I mean, traditional animation consisted of a lead artist drawing a few keyframes, sort of frame 1, frame 30, and then a junior artist would fill in all of them. And now there's sort of automated tools that help fill in all of that. So it's kind of a way of amplifying your artistic ability. And I think what will happen is that artists around the world will say, hey, this is really exciting. I can make art with this kind of generative sort of stuff. In fact, I was at the New York Museum of Modern Art a few months ago, and there was a huge, their largest single piece of art in that museum was actually computer-generated images, not realistic images, but it was sort of flowing and recreated sort of images and feelings and stuff like that. I thought that was really exciting, and I think we will see more of that kind of thing in the future. Maybe 40 years ago, if you went to a rock and roll concert, in between bands, somebody would come out with a keyboard and make fancy plunking noises of different sorts. Okay, this is very primitive synthesizers. And then pretty soon, rock artists said, hey, I can make music with these synthesizers, not just fancy noises. Okay, and I think the same thing will happen here with these kinds of tools.
There's an old quote, I can't remember, it might just be from a song lyric, I can't remember where it came from, but it's every artist is a forger and every poet is a thief. And I think that ChatGPT just gives you better ways of being forgers and thieves. So.
I think we kind of reached a limit, particularly for our visitors, I think, who probably are very tired. So unless there's a really, really burning question, I'm going to wrap things up. Any final question? Okay, so this is the final question.
Good evening, panelists. This is kind of a long question, so please bear with me. There are classifications of AI, those being AI, artificial general intelligence, and artificial superintelligence. The global perception of AI is that we are currently in the transition phase between artificial intelligence and artificial general intelligence. My question to all of you all is that being academics so involved and familiar in the field of AI, do you feel the possibility of achieving perfect AGI is achievable within the next 10 years? And also, is artificial superintelligence something that we may be able to experience in our lifetime?
Thank you for rephrasing my original question.
Not in my lifetime. Probably not in your lifetime either. I think another way to look at it is the kind of the scheme of intelligence that you find in the natural world around you. I mean, plants respond to different changing conditions and lighting. They move a little bit. Simple animals have patterns of behavior, but they respond to things in their world, in their kind of level of intelligence. You know, cats and dogs, and you know, so there's a general kind of schema of intelligence. I wouldn't necessarily put humans at the top of this schema, but we're certainly one of the most complicated kinds of things. And I think when it comes to AI, you will see similar kinds of things. At the moment, you see a lot of very specialized AI components that do one thing or another, perhaps as well as humans, sometimes even a little bit better than humans. These are very specialized kinds of things. I think you will find a little bit more putting together, but in a human, you've pretty much got all of these things put together now. I don't foresee really being able to do that in the case of a general purpose on AI. Like I say, not in my lifetime, probably not in your lifetime either. Maybe beyond that, perhaps. My opinion, though, some other people, have different opinions.
Okay, so I think, is it Nirmali?
I was just going to say I don't have a crystal ball and that I just don't know. That's it.
Just don't ask ChatGPT to make an evil version of itself. That's probably the best thing you can do.
Yeah, so I'm sure the person who asked the question has read, many people like Elon Musk and others who have kind of given much closer dates for these things to happen, right? But as Bob said, I think we are just beginning to unpack this thing called intelligence, right? And I think we'll see many more kind of thresholds to cross in the years ahead. So let me take this opportunity to thank our three speakers. Can we give them a hand? Let me also thank Mark Zab, who's here, who's also flown in today. Yes, thank you for joining us. And also for all those who registered early and came on time, thank you very much. And for those who asked questions and got some takeaways. Thank you to everyone, and hope you have a good day. Bye. Also, I should have thanked Havindra, who unfortunately had to go a bit early.